Assalamu alaikum. My name is Kashif Javed, and today the topic of my presentation is bioplastic. This presentation is submitted to our most respected Dr. Hammad Majid. First of all, we will come to know about the introduction of bioplastic. Bioplastics are special plastics that break down naturally and come from things like plants. They can help with the big problem of plastic waste that's hurting our planet and making the environment dirty. It does not really make sense to keep using regular plastic to package things that we use up quickly when it takes plastic so long to go away. Regular plastic is the third most used thing made from petroleum in the world. Every year we use 200 million tons of plastic. It's made from petroleum, which is not a source that can be replaced, and it does not break down by itself. It can take more than 1,000 years to disappear. Animals like sea turtles can die from eating plastic. That's why some countries like Bangladesh have banned regular plastic bags because they clog up pipes and cause flooding. In Africa, they call them a national flower because they are all over the place, and Europe has thought about putting a tax on them. Besides, this waste is the reason why marine animals and birds that eat plastic like whales, sea turtles, and albatross die, and it causes a big environmental problem like islands of garbage in the ocean. As another option, people are encouraging the use of bioplastics. They are made from natural materials like plant cellulose or leftover potato and cornstarch. They can break down completely, they are just as strong and flexible, and they are already being used in farming, making clothes, medicines, and especially for making containers and packaging. These special bioplastics are called PHA, and they are gaining popularity in European and American cities because they are good for the environment. The first known bioplastic, polyhydroxybutyrate, was discovered in 1926 by a French researcher, Maurice Limogny, from his work with the bacterium Bacillus megaterium. In the next 10 years, it's expected that these bioplastics will meet 10% of the demand for plastic in Europe. PHA or polyhydroxyalkanoate is a type of bioplastic. It's made by using bacteria to ferment natural materials like plants. For instance, you can use PHA to create car parts through injection molding and for various other purposes. PHA is obtained from bacteria such as Pseudomonas. When in its natural state, it's look a bit like clear kitchen wrap, but it's true bioplastic. Here are benefits of bioplastic. They help lower the amount of carbon emissions. They save energy during manufacturing. They don't use up non-renewable resources. Making them creates less waste that does not break down, which can harm the environment. They don't include unhealthy additives like phthalates or bisulfite. They don't affect the taste or smell of the food they hold. Bioplastics are the type of plastic made from natural materials. They can help make plastic production more eco friendly. In a circular economy, we use renewable or recycled plastics to make new plastic, and we use clean energy. After we use plastic, we either use it or recycle it. Compared to regular plastic made from fossil fuels, bioplastic can have a smaller carbon footprint, and they can be better in some ways. They can be recycled like regular plastic, and some can break down naturally in certain conditions. But there are downsides too. Making bioplastic can sometimes harm agriculture, compete with food production, and be more expensive. New methods can help turn a mix of regular plastic and bioplastic waste in better materials. To help people choose better plastic, we need to improve the rules for identifying and assessing bioplastic. Clear rules and financial support are also important to make bioplastic more common and sustainable. Non biodegradable plastic are causing serious environmental problems by piling up in landfills and oceans worldwide. This pollution harms animals and human health. Millions of seabirds and aquatic creatures have died due to plastic pollution. In 2020, the global plastic production increased by 36% compared to 2010. Because of this, there is a growing interest in using bioplastic to meet our plastic needs. Bioplastics have many advantages over regular plastic. They can break down naturally, have a smaller carbon footprint, use less energy, are versatile, have unique physical properties and people generally accept them. Bioplastic have potential to replace petroleum based plastics in various industries from car to medical applications. Packaging materials make up about 40% of all plastics produced, and a big chunk of them are used in food product packaging. Because regular plastic harm the environment in many ways, the food packaging industry is always looking for new and better materials. In an effort to find more eco friendly options and move away from plastic made from oil, a new kind of plastic called bioplastics have been developed. Bioplastics can be made from natural resources, break down naturally, or both. This review looks into the basics of food packaging, the different types of packaging, what qualities they need, and how they can be made and how bioplastics break down. It also covers the various types of bioplastics used in food packaging and what they are made of and how they work for packaging. Here are main findings and conclusion. The food packaging industry is making quick progress to create packaging that's better for the environment. This is done by improving natural biodegradable materials using physical, chemical, and enzymatic treatment, making new biodegradable materials, improving their properties, and increasing production, making regular plastic from renewable sources, and looking for new materials from nature. Now we discuss the environmental impact of bioplastics. The impact on the environment from plastics made with fossil fuels had led to focus on exploring plastics made from biopolymers. Bioplastics are the type of plastics that's appealing because they are more environmental friendly and non-toxic. In recent years, there been a lot of research into different sources of bioplastic and how they can be used. Biopolymer based bioplastics are used in various industries, including food packaging, pharmaceuticals, electronics, agriculture, automotive, and cosmetics. While bioplastics are considered safe, there are economic and legal challenges to using them. Plastic is a common material used in our daily lives, especially in packaging. However, this widespread use of plastic has caused a significant increase in environmental pollution, releasing harmful chemicals and a tiny bits of plastic when it breaks down. To address this, bioplastic alternatives have developed to make plastics that are water resistant, strong, and clear like regular plastic. This review focuses on environmental impact, how these new bioplastics are made, and where they are used. It also talks about using a technique called electrospinning to create bioplastic and their various uses. Food packaging is one of the main uses for plastic. Bioplastic is a type of plastic made from natural materials like crops, wood, and plant fibers. This article explains how we make bioplastics from these natural sources for using in food packaging. When creating bioplastic, we look at things like how they handle heat, how strong they are, how well they kept our air and moisture, and whether they break down naturally. We also discuss how bioplastics break down and how to deal with the waste from bioplastic. This article explores how eco friendly bioplastics are, their cost, and how they affect society. Bioplastic do have some challenges and be such as being less stretchy and not as good as selling things compared to regular plastic. We talk about ways to make them better, like adding substances called plasticizers. In many cases, bioplastic can work just as well as regular plastics for food packaging. They also break down naturally, which is better for the environment. Bioplastics are made from materials like starch, cellulose, wood, sugar, biomass instead of fossil fuels, which make their production more environmental friendly compared to regular plastics. Here you can see the bottles made from cellulose acetate. The environmental impact of bioplastic is a topic of debate because there are various ways to make the greenness, including water use, energy consumption, deforestation, and biodegradation. Bioplastic have advantages such as reducing greenhouse gas emissions and lowering the use of non renewable energy compared to regular plastic. Companies worldwide can enhance the environmental sustainability of their products by using bioplastic. However, bioplastic also have some negative environmental impacts like eutrophication and acidification. They contribute to eutrophication, which happens when too many nutrients enter bodies of water, leading to harmful algal blooms that harms aquatic life. They also increase acidification. This is mainly due to the use of chemical fertilizers during the cultivation of raw materials for bioplastic. Bioplastics have other effects on the environment, such as lower human and terrestrial toxicity and carcinogen potential compared to regular plastic, but they do have higher aquatic toxicity. They also led to stratospheric ozone depletion due to nitrous oxide emissions from fertilizer use in biomass production. There are minor environmental impacts like pesticide use on crops for bioplastic, carbon dioxide emissions from harvesting vehicles, high water consumption for biomass cultivation, soil erosion, soil carbon losses, and loss of biodiversity. They are mainly a result of the land use associated with bioplastic. Some bioplastics can are made from crops that are also used for food, which can lead to competition in food production. These are called first generation feedstock bioplastics. Second and third generation feedstock bioplastics use non food crops, waste materials, or algae as their source. Whether bioplastics or regular plastics are more preferable depends on what environmental impact one considers the most. The first known bioplastic polyhydroxybutyrate was discovered in 1926 by French researcher Maurice Lemogny from his work with Bacterium Bacillus megaterium. Difference between bioplastic and conventional bioplastic. Now we start. Regular plastic, which comes from oil, gas, is the third most used material made from petroleum in the world. Every year we use 200 million tons of plastic. Bioplastic, on the other hand, are made from natural materials like vegetable oils, corn, straw wood, and even recycled food waste. But not all bioplastic break down naturally, and some regular plastics can. Bioplastics are usually made from sugar based substances like starch, cellulose, and lactic acid. In 2014, bioplastics made up just 0.2% of the global plastic market, which was around 300 million tons in total. Our packaging using a bio based material called polylactic acid PLA, mainly from corn. It can break down in industrial composting. PLA plastics are better for the environment compared to those made from petroleum. Bioplastics are the type of plastic made from natural sources like vegetable fats, corn starch, wood, and even recycled food waste. Some bioplastics come directly from natural materials like starch and protein, while others are made through chemical process using substances like lactic acid and lipids from plants and animals. In contrast, regular plastics, often called petro based polymers, come from petroleum or natural gas. One advantage of bioplastics is that they don't rely on fossil fuels, which are finite and distributed unevenly worldwide, leading to environmental and political issues. Studies show that some bioplastics have smaller carbon footprint than regular plastics, especially when they made from biomass and used for energy production. However, some bioplastic processes are less efficient and have a larger carbon footprint than regular plastics. The difference between bioplastic and regular plastic is not just about where their raw materials come from, but also their molecular structure. Both long-lasting bioplastic and biodegradable ones exist, and they must be recycled to prevent plastic pollution. Recycling drop-in bioplastic is easier as they fit into existing recycling systems. Recycling bioplastic is more challenging and can increase sorting cost, lowering the recycling yield, and reduce the quality of recycled material. Biodegradability might be suitable end of life option for some applications like agriculture mulch, but it's not straightforward as it depends on polymers chemical structure. Not all bioplastics readily break down in the environment. Conversely, bioplastics that are biodegradable can also be made from fossil fuels. As of 2018, bioplastics made up around 2% of global plastic production, which was over 380 million tons. As research and investment in bioplastic grow and concerns about regular plastic increase, bioplastics are becoming more popular in some market even as regular plastic production continues to rise. Now we discuss about bioplastic discovery and development. Here is the list of bioplastic discovery of development according to the years. In 1862, Alexander Parks discovered the bioplastic and developed it, and there are so on. Now we come to the basic rules of bioplastic production. The International Union of Pure and Applied Chemistry defines a bio-based polymer as the polymer that comes from biomass or originates from components derived from biomass. These polymers, at some point during their production into finished products, can be shaped through flow. Number one, the term bioplastic is commonly used as the opposite of polymers derived from fossil resources. Number two, however, it's important to note that labeling any polymer from biomass as environmental friendly can be misleading. Number three, therefore, it's recommended to avoid using the term bioplastic and instead use bio based polymer. Number four, simply having a bio based polymer that resembles a petroleum based one does not necessarily mean it's better for the environment unless its life cycle assessment proves to be more eco friendly. Commercial uses for bioplastics are limited due to challenges in cost and performance. For instance, in Italy, a special law made it mandatory for shoppers to use biodegradable plastic bags since 2011. Bioplastics are primarily used for disposable items like packaging, dishes, utensils, pots, bowls, and straws. They can also be used as coating for paper, which is more environmental friendly alternative to the usual petrochemical coatings. Some bioplastics known as drop-in bioplastics are chemically identified to regular plastics but are made from renewable resources. Examples include bio-PE, bio-PET, biopropylene, bio-PP, and bio-based nylons. These drop-in bioplastics can easily integrated into existing production process because there are some chemical makeup traditional plastics. Additionally, they are dedicated pathways for producing bio-based products. Now we come to the industry and markets of bioplastics. Here is the list of different products and their production as tons per year. As first we discuss the catering products, they and the list of tons per year are given. So now we come to the next topic, that is bioplastic production. The process of bioplastic production typically involves several stages. Here is the general overview. The first one is raw material extraction. Bioplastics are made from renewable resources such as corn, starch, sugarcane, or vegetable oil. The choice of raw material depends on the type of bioplastic being produced. Number two, fermentation or extraction. For starch-based bioplastic, the raw materials like corn or potato undergoes a process called fermentation. This involves breaking down the starch into sugar, which can be used by microorganisms to produce desirable bioplastic. In the case of oil-based bioplastics, oil from plants like soya beans or palm are extracted. The third step is polymerization. The sugars or extracted oils are then subjected to a process called polymerization. This involves linking the individual molecules together to form long chain, creating the polymer structure characteristics of plastic. Number fourth step are additives. Various additives such as plasticizers, colorants, and reinforcing agents may be added to enhance the properties of bioplastic. Number fifth step is processing. The polymer is then processed into the desired form. This can involve methods like extrusion, injection molding, or blow molding, depending on the final product. Next step is modeling and shaping. The bioplastic is shaped into its final product using techniques called molding or extrusion. This step is crucial for creating specific items such as packaging, utensils, or other products. Next step is cooling and solidification. The shaped bioplastic is then cooled and solidified to maintain its form. Next step is quality control. Quality control measures are implemented to ensure bioplastic products meet the required standards. This may involve checking for strength, flexibility, and other performance characteristics. And the last step is packaging and distribution. The final bioplastic products are packed and distributed for use. It's important to note that different types of bioplastics may have variations in their production process based on specific raw materials and intended application. Additionally, advancements in technology contribute to improve the efficiency and sustainability of bioplastic production process. Here is the bioplastic production cycle from where the bioplastics are made from bio waste. Okay, the next step is discuss which we will discuss are the types of bioplastic. The first type we will discuss is polysaccharide based bioplastic. Polysaccharide based bioplastics, particularly starch based plastics, are widely used in the bioplastic market. In fact, thermoplastic starch makes up about 50% of bioplastics market. You can even make simple starch bioplastic film at home by heating starch and forming it into a film. Pure starch is good for absorbing moisture, which make it suitable for making drop capsules in pharmaceutical industry. However, pure starch-based bioplastic is somewhat brittle. To make it more flexible, plasticizers like glycerol, glycol, sorbitol can be added. This resulting bioplastic is known as thermoplastic starch and can be tailored to specific needs by adjusting the amounts of these additives. Starch bioplastics can be processed using conventional polymer techniques like extrusion, injection molding, compression molding, and solution casting. The properties of the starch bioplastic are greatly influenced by the ratio of amylose to amylopectin in the starch. More amylose typically leads to better mechanical properties. However, high amylose starch can be more challenging to work with due to its higher gelatinization temperature and melt viscosity. Starch based bioplastic are often blended with biodegradable polyesters to create blends like starch polylactic acid, starch polycaprolactone, or starch ecoflex. These blends are used in various applications and they are compostable. Some manufacturers have developed starch polyolefin blends that are not biodegradable but have a lower carbon footprint than petroleum based plastics used for the same purposes. Starch is cost effective, abundant, and renewable resource. Starch based films, often used for packaging, are made from starch mixed with thermoplastic polyester, resulting in biodegradable and compostable products. These films are used in consumer goods packaging, including magazine wrap and bubble film, as well as bakery and produce bags. These are also used in composting bags for collecting organic waste. Starch based nanocomposites have been studied and found in the improved mechanical properties, thermal stability, moisture resistance, and gas barrier properties. Now we move to the next type, that is cellulose based bioplastic. Cellulose based bioplastics mainly involve cellulose esters like cellulose acetate and nitrocellulose as well as their derivatives like celluloid. Cellulose can become thermoplastic when modified extensively as seen with cellulose acetate, which is rarely used for packaging due to its cost. However, combining cellulosic fiber with starch can improve mechanical properties, gas permeability, and water resistance. In the novel development, a group of Shanghai University created a green plastic based on cellulose through a method called hot pressing. The next type of bioplastics are protein based bioplastics. Protein based bioplastics are the type of biodegradable plastics made from proteins sourced from different places. Foreign tense substances like wheat, gluten, and casein are showing potential as the main ingredient in creating different biodegradable plastics. Soy protein is another option for making bioplastic. In fact, soy proteins have been used in making plastic for more than 100 years. For instance, the original Ford car had body panels made from soy based plastic. However, there are challenges when using soy based plastics. Primarily, they can be sensitive to water and are relatively expensive. To overcome these issues, scientists are working on mixing protein with existing biodegradable polyesters to improve water resistance and reduce cost. Now we move to the next type, that is lipid based bioplastics. Bioplastics can also be made from fats and oils obtained from plants and animals. Various types of bioplastics such as polyurethanes, polyesters, epoxy resins, and other polymers have been developed with properties similar to those derived from crude oil. Recently, olefin metathesis, a chemical process, has expanded the range of materials that can be efficiently converted into bio based building blocks, monomers, and polymers. This development, combined with the increased production of traditional vegetable oils and cost effective oils derived from microalgae, opens up significant opportunities for growth in this field. Now we move to the next type, that is aliphatic polyesters. And the example is PLA, polylactic acids. PLA is a form of polyester made by fermenting ingredients like corn, starch, or sugarcane. This is currently the cheapest bioplastic on the market. It's commonly found in food packaging, clothing, cosmetics, and home furnishings. Here you can see much film made from PLA blend bioflex. Now we discuss the applications of bioplastic. Bioplastics can help us use less fossil fuels, which are really bad for the environment. They are made from things like corn, oil, sugar beet, and plants, so they are better for the earth. Traditional plastic can cause a lot of harm, so using bioplastic can actually reduce pollution. In the future, you will see more and more things made with bioplastic, like packaging, food containers, and even parts in phones and cars. Now we discuss the first application, that is bioplastic packaging. People are quickly using more bioplastic instead of regular plastic for packaging. A lot of folks want packaging made from bioplastic, and in Europe almost half of the bioplastic, around 44%, are used for packaging. In 2017 there are about 2.05 million tons. Bioplastic packaging comes in various forms like compostable bags, agriculture foils, and even toys. They are used for things like disposable cups, salad bowls, and food containers too. Using advanced bioplastic packaging for food helps the food last longer, and it also shows that brands care about the environment. But most packaging is still made from regular plastic, and a lot of it ends up in landfills. Governments are working to change this. Bioplastics offer a better way to package things, and they break down naturally when they are not needed anymore. Manufacturers find it easy to make bioplastic packaging because they can use the same technology as regular plastic. This change to bioplastic packaging is expected to make our daily lives better without any major downsides. Now we move to the next application, that is bioplastics for consumer electronics. The electronics industry is working to be more environmental friendly. They are focused on making devices that use less energy and can be recycled better. Now they are also looking at the materials they use. Bioplastic can help the electronics industry be more eco-friendly. They can be used in similar way to regular plastic without needing to change the machines that make electronic parts. Many electronic parts like casing, circuit boards, and storage are usually made from oil-based plastics. Switching to bioplastics for these parts is a great idea. There are a lot of opportunities to use bioplastic in things like computer casings, speakers, headphones, keyboards, phone casings, laptops, game consoles, and vacuum cleaners. Using bioplastics for electronics is a bit tricky, but they are processed at lower temperature than regular plastic. In the past, this caused problem with how well they could handle heat. But now new technology has improved it, making bioplastics a good option for making electronic parts. Now we move to the next application, that is food service. Many people today like to buy food and drinks when they are on the move because they are busy. But this also means more waste, and it's important to get rid of it properly. Bioplastics are making a positive difference by helping to lessen the impact of this waste on the environment. They are used for things like lids on coffee cups, disposable cutlery, plates, and containers for all kinds of food. Now we move to the next application, that is medical. Doctors are now using special stitches made from biodegradable bioplastics in hospitals. These stitches are easy to clean, strong, and stay in place until the body heals. Once the healing is done, the body naturally dissolves them, leaving no marks. Biodegradable plastics are also used for medical devices like pins, tags, and screw used in surgeries to help bones heal and during reconstructive surgery. Even dentists are using bioplastic for dental implants that fill the gap left after a tooth is removed. Containers for bioplastic tablets and creams can also be made using bioplastic. Just like regular medical products, bioplastic component can be made in a clean and dedicated environment. Now we move to the next application, that is aerospace and automotive. Cars and airplanes are a big part of why the earth has a lot of carbon emissions which are bad for the environment. Now, the people who make these vehicles are trying to design ones they are better for the planet. Government and consumers want this change, and one exciting this thing happening is the creation of hybrid cars. The car and airplane industries are spending a lot of time and money figuring out how to make their vehicle lighter so they use less fuel and produce fewer emissions. Plastics are often used to help with this, and now they are looking at using bioplastic. Safety and how well the vehicles work are super important. The good news is that bioplastic can be just as good as regular plastic in meeting these standards. Before, plastics in electronic products needed to handle high temperature, and the same is true for parts in airplanes and cars. Now that bioplastics can do this too, we are likely to see more and more of them being used in these industries. Now we move to the next application, that is in cosmetics. The makeup industry uses a lot of packaging for its products, and many of these products get thrown away quickly, ending up in landfills. Things like toothbrushes, hairbrushes, cotton buds, and razors also add to this waste. Brands are now searching for better options. People who buy these products have certain expectations, and brands want to meet those without compromising on quality. Bioplastic alternatives are a way for brands to do this. Even small parts of cosmetic products like caps can be made using bioplastic through a process called injection molding. Thank you so much. This all from my side.